example. We've again got a set of 3 equations. We need to start with picking out a pair of them and eliminate one variable. Well, I'm going to take the first pair and I'm going to eliminate the variable y. Okay, so that would be that I've got the 2x minus y plus 2z equals 6, and I've got a negative x plus y plus z equals 0. Notice I actually don't need to actually do anything to eliminate the y, because they go ahead and cancel out. The negative y and positive y cancel out when you add. So I can just add normally, which says I've got the 2x and a negative x, which when added up will just give us a positive 1x. I also have a 2z and a z, which will add and become a positive 3z. And equals on my other side of my equation, I also have a 6 and a 0, which when added together will give me 6. Now, I need to do the same thing again, or actually something really nice is occurring in this example is look at this last equation. It's actually only got x's and z's, so I don't need to do elimination. I've got another equation that's got x's and z's already. What's also very, very awesome is it's already set up for elimination, because with my other equation, I have a plus 3z, and now with this one, I have a negative 3z. So let's see what happens if I just go ahead and use elimination on these two. I've got a x plus 3z equals 6, and a negative x minus 3z equals negative 6. Well, if I go ahead and add these, like normally when you eliminate, let's see what happens. Well, the x's will cancel because one's positive and one's negative. The 3z and negative 3z will cancel, so that means everything canceled. You get a 0 on the left-hand side. Equals, well, notice on the right-hand side you also have a plus 6 and a negative 6, which when added will cancel out and give you 0 as well. Okay, 0 equals 0. We know that that's a true statement. What does this answer mean then? This means that these equations are going to be always true for any triples x, y, and z. So this is going to have infinitely many solutions. Now let's take a look at a couple examples where we're looking at word problems. Here, the main point of these is to make sure that we can set up the equations correctly, because solving the system of equations is just going to be done the same way, just using elimination multiple times. So as long as we can set up the equations correctly, we should be okay to do the actual solving of the equations. So that's all we're going to focus on, is actually setting up the equations. So let's take a look at this first one. A water distributor wants to make up 300 gallons of water to sell for $7 per gallon. She wishes to mix it with 3 grades of water that normally sell for $14, $3, and $4.50 per gallon, respectively. She must use twice as much of the $4.50 water as the $3 water. How many gallons of each should she use? So first of all, let's decide what letters we're going to use. Well, let's use X, Y, and Z. And let's X be however much of the $14 water. So the amount of the $14 water. Okay, and Y will be the amount of the $3 water. And let's see, Z will be the amount of the $4.50 water. Okay, now let's work on actually coming up with our equations. Now the first thing that they tell us is that we want to have a total of 300 gallons. So what does that mean? It means that however much of all three needs to add up to 300 gallons. So that means our first equation is the x, the y, and the z all added up to a total of 300 gallons. Next, we need to bring into the equations is the actual prices. Well, let's see. We've got that she wants to, let's see, the first one, however much of the 14-gallon water is the X, so we're going to have $14 of however many gallons of the X plus however much of the Y, which is a $3, so 3 times the Y, and then $4.50 is how much our Z gallons of that $4.50 gallon water. And at the end, it should equal, well, at the end, we want this to be a total of 300 gallons, and we want to charge $7, so 300 times 7. Okay, we've got 2 out of 3 equations now. Our last equation has to come from this last sentence, which says that we're going to use twice as much of the $4.50 water as the $3 water. Well, the $3 water is Y, and we're going to use, let's see, twice as much of the $4.50 water. So, how do we translate that? So, if she needs to use twice as much of the $4.50 water as the $3 water, what that means is she's going to use twice as much of the $4.50 water as the $3 water. That would look like, this would look like that Z, or $4.50 water, is going to be twice as much as the $3 water. And the $3 water, we use the letter Y. So those are our 3 equations we would use. Now, if you're actually going to do your elimination, I would make sure that you go ahead and do your multiplication, the 300 times 7 first, which is 2100. So don't forget to do that, because you do have to follow order of operations. And again, you do substitution and or elimination. Notice they did actually do something nice for you here with one of the equations. You are set up to do substitution a little bit here. You can make your life easier by substituting any z's with this 2y according to this third equation here. And then after that, then you can use your final substitution or elimination to get it down to either y's or x's. But this gives you a good idea on how to set up the equations, which is the hard part.